This is Microeconomics Lecture number 9 on market equilibrium. Let's learn some economics. What we're dealing with in this lecture and in the next one is the concept of equilibrium itself. And really, when all is said and done, equilibrium means balance. And so what we're looking at is balance. And what we're discussing is the balance of the different forces in economics. What we're going to look at is we're going to look at in the first lecture, number 9, we're going to look at market equilibrium, which is really the balance of supply and demand. And we're going to take a look at that. And then in the second lecture, in number 10, we're going to look at the balance for profit, which is basically costs and which is to say money out, and prices and money in. And we'll take a look at that, and we're going to see. We talked a little bit about profit maximization in the previous lecture, and we're going to talk about how that's going to shift based on certain factors. And that's we're going to talk about the shifting in the market in this lecture. And really what we're answering is we're answering one of the questions that we were left with, because if you recall in some of the problems that I presented in the lectures, we went, particularly in lectures 3 and 4, when we figured out how to come up with the linear function of demand and the linear function of supply, I would posit, well, how much is going to be demanded for a certain price? How many will be demanded? And we figured that out, and we figured out, well, how many will be supplied for that amount? And we figured that out, and it wasn't the same number. And we really were left with the idea that, well, what we really want is some way of figuring out the point at which the price that we charge is going to get both the same amount of supply and the same amount of demand, so that supply and demand will be even. Okay? Well, we're going to figure out how to do that now, and we return to our, I suppose by now, famous or infamous fish sandwich example from our local tavern. Okay, and what you see here is the table that we've been using throughout. I think I introduced this for the first time way back in lecture 3 when we were talking about demand. Here we have the demand function, right, and the demand schedule, which is nothing unusual. This should be by this point in the half semester. This should be old hat for us. This is the supply schedule to go along with it. And these are both things that we've seen before. When we went through in lecture 3, we went through the demand, and we figured out how to figure out the linear demand function based on this schedule, and we came up with this line right here, okay, which told us that for $2, 300 will be demanded, etc., etc. And we looked at that, and we came up with a couple of other examples of it. With supply in lecture 4, we did the same thing, and we came up with this line. Well, really, when it gets down to it, market equilibrium is a correlate condition, meaning it is a logical conclusion drawn from what's said before. Okay? We posited way back in lectures 3 and 4 the law of demand and the law of supply, and the law of demand suggested a negative correlation between price and quantity. We see that depicted here. We see higher prices, lower quantities, lower prices, higher quantities. That was the law of demand. The law of supply was diametrically opposed to that. We had a positive correlation between quantities and prices, and so we have that depicted here. We have at the higher prices, higher supply; at the lower prices, lower supply. Well, if you place both of those on the same grid, it is an inevitability that they will intersect. They have to. The question, of course, is where will they intersect? They will intersect at a unique point, okay, given the two functions. Now let's take a look at how we'll figure out what that point is. Some of you have probably jumped to this conclusion already. It's a simple algebraic solution to it. You're basically just going to set the supply function equal to the demand function, and we'll walk through that in a step-by-step process to figure out how that's done. And this is just kind of reiterating what I've just said. For demand in lecture 3, what did we conclude? We concluded this function, and you can go ahead back to lecture 3. Hopefully you printed out the PowerPoints. If you didn't, you can just jump back and take a look at them, and you'll see that when we were working with the demand function for this particular example, we arrived at this for our linear demand function. Now, what I want you to keep to reiterate in your mind is a basic mathematical argument, which is that this over here, quantity equals 360 minus 30p, excuse me, is just another way of expressing this. They say the same thing. They are synonymous. And which of these two we use isn't really going to matter. As long as we use the same type of expression, we'll call this a demand function. We'll call this the inverse of the demand function. Doesn't matter which one we use. We're going to get to the same place. Okay? And it's going to be largely a strategic approach to it, whichever we find simpler. Okay? So there's a lot of strategy that you're going to want to employ in solving this problem. Okay, and then for supply in Lecture 4, dealing with the same example, we came to the conclusion that this was our supply function. This was the inverse of it. Again, this is simply a restatement of this. They are the same. To establish equilibrium is then a relatively simple and rather mechanical process of calculation. Okay? And it doesn't matter which we do. Okay? There's a lot of freedom in terms of how you approach this. What gives you that freedom, though, and I've stressed this point before, and I will stress this point again. Don't get lost in the mathematics of what we're doing. The math is relatively simple. We're employing literally junior high algebra. Okay? But we have to keep in mind conceptually what we're doing. Well, conceptually what we're doing is we want to find a point, a price and a quantity. Every point has price and quantity. Those are the only two variables we're dealing with at this stage. We want to find a point, okay, which is to say a price and quantity, where supply equals demand, meaning that supply and demand are the same at that point, okay? To do that, we set supply equal to demand. Now, we can either figure it out. What we're going to end up doing is figuring out either the price of equilibrium or the quantity of equilibrium. Once we have one of those two things, finding the other one is a very simple matter. All we have to do is substitute it in the appropriate place in whichever of the two formulas we choose to use. And it doesn't matter which, because supply and demand will be the same at that point. Okay? You see that I've walked you through how to do that here. In this case, we're using the basic demand, the basic functions. Here was the demand function. Here was the supply function. We simply walk through a little basic algebra. Okay? We bring the 6/7 over here. It becomes negative 12 minus 6/7 equals 1/30th q plus 1/35th q. We find the common denominator, 35 1,050th q plus 30 1,050th q equals 84/7 minus 6/7. 78/7 equals 65 1,050th q, which is, I'll grant you, I'm going to show you how we're going to get rid of that number altogether. Because I don't know about you, but the way I'm looking at it, I wish there were a simpler way than having to use a fraction like that. Well, as it works out, there's going to be. Okay, but what I want you to remember now, okay, let's not get lost on this. When I set this problem up like this, when I use the demand function and the supply function, my variable is q. What this is going to find me is the quantity of equilibrium. It's going to find the point where supply and demand will match each other in quantity. That will give me the quantity of equilibrium. Okay? We simply run through the math. We end up with this number here, and so quantity is 180. But I agree, doing it with that fraction there, I know most students don't like fractions. I'm a fan of fractions, but even that fraction there, even that, it seems just a little unwieldy. It would be nice to find it a different way. Now that we've determined that quantity, finding the prices is child's play. Okay? Doesn't matter which formula we use. Keep in mind, okay, conceptually keep in mind that what that number means is at that quantity of production, 180, supply and demand are the same thing. So it doesn't matter which of those formulas we use. Plunk it in its appropriate place, meaning wherever you see quantity in one of those formulas, plunk in 180 instead, because that's now the quantity we found. Okay, so if we use the demand function, 12 minus 1/30th Q, we simply take this 180 and put it in and substitute it for the Q. Okay, well, that means 12 minus 1/30th times 180. 1/30th times 180 is 6. 12 minus 6. $6 is our price of equilibrium. If we use the supply function, note, okay, walk right through this, you end up at the same place, which is what I've been saying. Okay, so what we're going to end up with is the point of equilibrium is price of $6, quantity of 180. What does that mean? That means if we charge $6, supply and demand will be the same. Okay, we will have demand for $6, demand will be 180. For $6, supply will be 180. So we've achieved our purpose. Okay, that's where we are. Now let's see if we can get there faster, or at least easier. And you see what I say here, the decision of which version of the function to use, whether you use the function itself or the inverse of the function, is largely based on simplicity and choice. What we enter into here, really more than anything else, is what's known, I'm not sure if you've ever been introduced to the idea of Occam's razor. Occam's razor is an epistemological postulate, and it basically says that whenever you have alternative explanations, all of which get you to the same place, all of which get you to the same explanation, the simpler of those explanations is preferred. Okay? There is a certain attraction to the path of least resistance, is I suppose what it means. Okay, so in determining Q, we used the demand and supply functions, because in the demand and supply functions, that's our variable. Okay, they're phrased as P equals down to Q. Okay, well, to calculate P, we can use the inverses. Now let's look at this strategy. When we dealt with demand, if you remember the demand function, this was the inverse of that function. They are the same thing. They state the same thing. Okay, and this was the inverse of the supply function. I don't know about you, but from where I'm looking, that looks like it's a lot easier to work with because there's no fraction. All right. This is what this is going to give me. You see the variable here. Okay. The variable here that will be calculated is P. Okay, so this is going to give me the price of equilibrium. What I just calculated using the demand function and the supply function was the quantity of equilibrium. Don't need to do that. I can find the price of equilibrium and it will get me to the same place. Okay, I'll set these two things equal to each other. That'll give me the price of equilibrium. That'll give me at the point of equilibrium what the price is. Then I can just plunk that price in. I can substitute it in its appropriate place in either of the two functions to get the quantity. So here we have this. We just walk through the math here, which I think from my way of looking at it is a lot simpler. 360 minus 30p equals 35p minus 30. We do a little simple algebra. We end up with 390 equals 65p. We divide both sides by 65. $6 is our price, which is what we came up with last time. Okay? Doesn't matter which one of these two things we use. This one seems a little simpler to me. Okay? We substitute this P in either the supply or the demand function, and we arrive at Q equals 180. Okay? Put it right here. I can do this one in my head. There's not much I can do in my head, but this one I can do in my head. 360 minus 30, we just figured out P is 6. So 360 minus 30 times 6 is 360 minus 180, which is 180, which is what we figured out. Okay, we could do it here too. It's not that much more difficult. 35 times 6 is 210 minus 30 gives me 180. Okay, you get the basic idea? Doesn't matter. And I know we would like, one of the things that I like about algebra is that there isn't simply one way to solve something. Which way we use is oftentimes simply a matter of preference. It's a strategic approach to the problem. What I'm trying what I've been working with you guys is to develop problem-solving ability. Okay? Ultimately, and this is, I suppose, the main purpose when all is said and done of a college education. Okay? The information that you learn, yeah, it's interesting enough. It's relevant enough. Am I actually ever going to use this in my day-to-day, workaday life? Maybe not. But what I will use on a daily basis, multiple times a day, is the process of thought, okay? That thinking process, okay? Problem solving. And so that's what we're working with, is problem solving, okay? Now, based on what we've just done, this is what the graph of equilibrium is going to look like, which is, if we recall from the very beginning of this lecture, some 15 minutes ago, this was what we were looking at. Okay. Now, as it works out, in the example that we've been using, the example of this local tavern and their supply and demand for fish sandwiches, as we've been looking at that, just from looking at the table, you can see where equilibrium is. I set that problem up very nicely the way economics textbooks do. Okay, not all problems look like that. I can't just look at the schedule and see where equilibrium is going to be. I might be able to approximate it, see basically where it is, but I need this methodology to figure out precisely where it is. And what we're going to see is, once we've figured that out, okay, we're gonna extend that and figure out what the profit is at that level, and what consumer surplus is, which I haven't really talked about yet. We'll talk about it here. Okay? And so you see everything modeled here. Here's our supply function, if you'll recall. Here's our demand function. That's the equation of this line. This is the supply line. That's the equation of this line. This is the demand line. There we have the two equations. What we did was we set those equal to each other, and we arrived at the price of equilibrium being $6, the quantity of equilibrium being 180. Now, we'll deal at length in a later lecture on the idea of market failure. I can't remember off the top of my head. I think it's the last lecture that we do this half-semester, is on what's referred to as market failure. The basic run-of-the-mill, garden variety, most common form of market failure is a failure for markets to clear. Now, what we mean, a market is said to clear. A market is cleared when the supplier provides as much quantity as the demander demands. When that happens, the market is clear. Imagine, simple, okay? The simple thing to imagine is, imagine a farmer's market. Imagine a flea market, okay? Well, what we mean by a market cleared is literally the market is cleared. The people that are selling things brought exactly the right amount to the market to satisfy the demand of the people that came to the market to buy. At the end of the day, there's nothing left. That's a clear market, okay? In orthodox economic theory, what we contend is that, and this is in monetarism, which is the modern form of this orthodox theory. This is kind of Adam Smithian stuff, Wealth of Nations type stuff, okay? In its modern setting, it's really monetarism is the descendant of this, okay? Is that markets have a tendency to clear. This is what we're going to deal with when we talk about the invisible hand. Okay, markets have a tendency to clear. When they don't clear, we end up with one of two conditions. The first we'll go over is called a shortage. Very simply defined, demand is greater than supply. The people that come to market that want to buy walk away unsatisfied because there isn't enough supply. The other is a surplus. That's when demand is less than supply. Producers have brought too much to market. At the end of the day, they have to take some of the stuff home. Okay, they end up with an excess in inventory. All right, that's your basic form of market failure. And what Adam Smith talked about in The Wealth of Nations, and what is one of the more famous things we talk about in economics, is this mysterious invisible hand. Well, what the invisible hand suggests is that without any interference from government agencies or from anything, the market has a natural tendency to clear. Okay, and we'll look at how this is. Okay, if you have a shortage, okay, in other words, if there's too much demand and not enough supply, what's going to end up happening, because you have too few units, what we looked at before when we talked about demand. And when we extended demand in lectures 5 and 6, we said, oh, well, the more you have of something, the less valuable each of those things is. Well, in a shortage, you have too few. When you have too few, each of them becomes more valuable. Okay, so what's going to happen is there's going to be a natural tendency under a condition of shortage for prices to increase. And what's going to happen is prices increase, supply will go up because of the law of supply. The higher the price, the greater the quantity of supply. So as prices increase, supply will increase. As prices go up, demand will drop. Those two will come together and meet, and the market will clear. Exactly the opposite condition is going to happen if you have a surplus. If you have a surplus, you have an overabundance of supply, meaning you have too many things. Well, what did we see in lectures 5 and 6? We saw, well, if you have too many, each of them is worth less, relatively less. Okay, which means that under conditions of surplus, prices are going to drop. As prices drop, supply goes down, demand goes up, and the two things will again meet, and the market will clear. Okay, so there's a natural tendency for markets to clear. This is, we see the graph now of surpluses and shortages. This is our price and quantity to equilibrium. Here's the price of equilibrium. Here's the quantity of equilibrium. In the example we've been using throughout, $6 and 180. Now, if the price is too high, okay, if the price is greater than $6, if the price is higher than the equilibrium price, that means producers are going to be producing too much. Okay, the higher the price, the greater the quantity. That's the law of supply. It means producers are going to be producing too much. The higher the price, the less demand. It means that demanders will be demanding too little. This will end up with a surplus. You'll have too much supply. Okay, you'll have supply over here at this quantity. You'll have demand over here at this quantity, and you'll have a shortage, or a surplus rather. With a shortage, exactly the opposite condition. If the price is below market equilibrium, the artificially low price is going to create too much demand and too little supply, and you'll end up with a shortage of this length. Okay? And so I could ask you questions. How much surplus is going to be produced? How much shortage is going to be produced? Okay? And you could just kind of do that just to test yourself. You could figure that out right now if you said, okay, we just figured out that the price of equilibrium is $6 and the quantity of equilibrium will be 180. Well, if we charge $7.50, how much surplus is going to be produced? Or how much shortage is going to be produced? Okay, well, for $7.50, that's a price that's above the equilibrium price. So we'll have supply over here and demand over here. Okay? Now let's look at shifts in equilibrium and what that's going to look like. First, again, here's our original equilibrium, PE1 and QE1. That'll be our original equilibrium. What we've been using throughout is what we just calculated was $6 was the price, 180 units was the quantity. That's our original equilibrium. Well, what happens if we have a shift in demand? Should we go through and review, as we often do, what the shifts and what would cause these shifts in demand? If you recall, I think it was way back in lecture 3, what we dealt with in terms of demand shifting. Assuming that our product, the fish sandwich, is a normal good, if there's an increase in income, demand will shift this way. If there's a decrease in income, it will shift this way. And what were the other reasons for shifting? We had the price of related goods, complementary goods, substitute goods. We had future expectations. We had consumer tastes, etc. Okay, that's what's going to shift our curve. Question is, what's going to happen to equilibrium when we shift that curve? When we shift that curve? Well, with demand, if we increase demand, okay, notice what happens. Notice that the price and the quantity of equilibrium will go in the same direction. In other words, if demand increases, price and quantity will increase. You'll have an increase in the price at equilibrium. You'll have an increase in the quantity at equilibrium. Whereas if demand decreases, if you have a shift in demand such as it's a decrease, the same thing will happen. They'll go in the same direction. You'll have a reduction in price and a reduction in quantity. And again, I want to stress the point, as I've done before, that when we are dealing with shifting the demand curve, we are not dealing with the variable of price and quantity. Price and quantity will be the result of the shift, not the cause of the shift. The cause of the shift will be any of those factors we just mentioned that shift demand. Changes in income, changes in the price of related goods, changes in consumer tastes, future expectations, the number of buyers, in the market, etc. All right, that's what's going to shift this. And so if we use this basic garden variety example I've been looking at throughout, if we look at something like, I mentioned it before, this place down here in Ohio, this Rogers, Ohio, which is the largest flea market that I've ever been to, right, where you've got 2,500 stalls on a given summer in the weekend, on a given Friday morning. Okay, well, where this demand curve is and where this equilibrium point is going to be depends on how many people show up. Okay, on a kind of a nice, sunny, warm day, everybody's out there, everybody's shopping for their little knickknacks and their crap at flea markets the way people do. Okay, you're going to have the demand curve shift outward. And so prices are going to be higher. Quantity at equilibrium is going to be higher. Okay. Whereas if you deal with a rainy day, a cold day where nobody wants to go out, nobody really wants to buy anything, then the demand curve is going to shift downward. Okay. So this is what's going to happen when we shift demand. And we'll work with that in future lectures a little bit. With supply now, okay, we want to pay attention to this. It's kind of the opposite that's going to happen. And what I mean by that is what we saw with demand shifts was that price and quantity of equilibrium go in the same direction. Okay, if we increased demand, price and quantity went up. If we decreased demand, price and quantity go down. When we shift supply, the opposite condition is going to happen, which means that price and quantity are going to go in opposite directions. Okay, this shouldn't surprise us. Supply and demand are diametrically opposed to each other. Whatever is true of one, the opposite will be true of the other. And so when we shift demand, if price and quantity of equilibrium go in the same direction, when we shift supply, we would expect price and quantity of equilibrium to go in opposite directions. Okay, and again, let's, by way of review, let's go through this and just kind of very quickly review. And again, I stress, when we're dealing with shifts in the supply curve, the price and quantity, are the result of the shift, not the cause of the shift. The cause of the shift will be any of those factors we discussed in Lecture 4 regarding supply shifts. So, and what did we have? We had cost of production, future expectations of demand, number of suppliers, right? I am listed down here, right? So we have increases in supply, more products. Oh yeah, alternative production possibilities was the one that I kind of forgot right there. All right, so that's what's going to cause our supply shifts. When we decrease supply, now why would we decrease supply? Supply will decrease if costs of production go up, if the number of producers goes down. Okay, if you have fewer people in the industry, somebody goes belly up, right, goes bankrupt, quits the industry, exits the industry. Nobody likes a quitter, but if they leave the industry, if government regulations, taxes, any of that, that'll increase the cost of production. We talked about that before in Lecture 4. If alternative production possibilities come up, okay, if another product is more attractive, supply for this product will go down. We'll have an upward shift in the supply curve. All right. Well, if we have an upward shift in the supply curve, note what happens. Okay, and you just have to draw the graph to see what's going to happen. You're going to have an increase in prices and a decrease in quantity produced. And this is a situation. Actually, this is the more, I guess I would say, at a macroeconomic level, the more dangerous of the two. I was just talking about this with a history class where I'm doing U.S. history too, which covers U.S. history from the Civil War until modern times. Well, in the 1970s, as a result of the oil embargo against the United States and Holland in October of 1973, you had what we referred to as price shocks. What you had was a quadrupling of petroleum prices. Well, that increases the cost of production. And so you have this situation here. Well, at a macroeconomic level, what this situation here is going to mean is an increase in prices, which is called inflation, and a decrease in productivity, which will actually increase unemployment. As productivity drops down to QE2, you're producing less, so you need fewer workers, okay, and as a result, unemployment. And this will create actually a condition of stagflation, okay? The opposite is true if we increase supply, if we reduce costs of production, reduce corporate taxes, reduce any of that, if alternative production possibilities. If an alternative product that we're producing, if we're producing two things, and the alternative product becomes less profitable, we'll throw our resources into producing this product, okay? And that was kind of the question. If I recall, I asked on one of the quizzes a question about, well, if the Bureau of Labor Statistics reports that the mean salary for nurses goes up a certain amount and the mean salary of computer technicians goes up a certain amount that's less than that, that was really a question of alternative production possibilities. Okay? The more profitable enterprise will attract more producers. Okay? The less profitable enterprise will attract fewer producers. Was the basic idea behind that question. Well, that's what we have here. All right? If we have one of the two alternative products that becomes more profitable, it will attract more producers. The supply curve will shift outward, and what happens? You have a reduction in price and an increase in output, okay, at the equilibrium level. And again, I stress, remember, when we deal with supply curve shifts, as we dealt with demand curve shifts, we're not dealing with price and quantity as a reason for the shift. Anytime we deal with price and quantity, that's movement along the line. And you see, that's what we're dealing with here. Okay, when we looked at the demand shift, that demand shift resulted in movement along the supply line. Well, now we're dealing with supply shifts, and note what we're actually doing. We're moving price and quantity along the demand curve. Okay, and we can have a lot of fun with this. This is where we start to have a lot of good fun, because we can have ourselves a supply curve shift that increases supply, dropping price and increasing the quantity equilibrium. Well, what happens now that because we've shifted it down here? Well, what happens if now there's a shift in income? Okay, at a macroeconomic level, we would expect that to happen. Why? We would expect that to happen at a macroeconomic level because, okay, we shift supply outward. So people are producing more. When they're producing more, you see, quantity goes from here to here, from QE1 to QE3, which means you need more laborers. Well, when you need more laborers, that means demand for labor goes up, which is going to push the wage of labor up, which means people are going to make more income. And when they make more income, they're going to demand more. And so what we would expect to have happen then is a demand shift. Well, what happens now if we shift from E1 to E3, and now we have a demand shift? We have an increase in demand. Well, that's going to shift us out this way on this new supply curve. Okay? We ultimately could shift it all the way to the point where the price becomes the same, but you have this massive quantity equilibrium increase. Okay? And so one of the things that I try to get at is, this was our original point of equilibrium. Well, equilibrium exists as a theoretical construct. There is a natural tendency for markets to clear and for the market to seek this point of equilibrium. But the market actually adheres to a given point of equilibrium only for a brief period. It's what's known as a Hamiltonian set in mathematics. Okay? Hamiltonian sets are a derivation of chaos math. Okay? Which means that any stable point exists only for a limited period of time. Okay? It exists, but only for a short time. Then it is going to be destabilized again. Okay? So once we've achieved this equilibrium, as soon as demand shifts or supply shifts, this point of equilibrium is going to be disturbed. The market will seek a new equilibrium, and this process will continue ad nauseum. This is what economics is all about. This is constantly changing. Okay? this equilibrium point based on supply and demand shifts. Now, here's where it gets really interesting. Here's where it gets really fun. I mentioned this in the lecture where we discussed costs. Okay, the number of which escapes me right now. But the lecture where we discussed costs. What the supply curve actually is, if you look right here, this looks very much like a supply curve. Okay? The supply curve is actually the average total cost curve after it intersects with marginal cost. Okay? We have a point where, and remember this, you can remember this from the cost lecture. Here we have marginal cost dropping down to a minimal point, which we called the point of capital saturation. Average total cost mimics this. Okay? Eventually the two of them intersect. This will always happen. Question is, where does it happen? That's not really our interest right now, although we will find it, although we will come to the understanding of it conceptually. Okay? Well, once they intersect, average total costs and marginal costs are both going to go up. Average total cost goes up. This becomes our supply curve. This is what's going to make it possible for us, just on the graph alone, to figure out how much profit is going to be made. All right, and we'll see how to do that in just a second. The key thing to understand here, though, conceptually, is that the supply curve that we've been working with, that supply function, is simply the average total cost curve after it intersects the point of marginal cost, which is to say, after it reaches its minimal point. Okay, and so now, if you're really good, if you're sharp, jump to the understanding. Put these two things together. Okay, this point, that's going to be the supply intercept of the y-axis. Okay, that's that point. The A, remember our supply function, P equals A plus BQ. If you remember all the way back to that, that's going to be A right there. That's going to be where marginal cost intersects average total cost. Aha. Now let's take a look at that. Here's the graphic reiteration of what we've just said. Here's the y-intercept of supply. That equals marginal cost equals average total cost right here. This then becomes our supply curve. It is also our average total cost curve, constantly increasing from this point. Okay, when we superimpose demand, the demand curve on this, it will cut down like this. It will descend, be negative sloping, as they say, and at some point intersect this supply curve, at which point you will have equilibrium. Now, and we're going to walk through this. We're going to take this slow and walk through it. Okay? But we want to go back and scratch our brains for a second and remember our basic middle school geometry, which we haven't had to remember since we took the SAT. We want to think about the area of a triangle. Okay? Here's our average. Let's think about this. Here's our average total cost curve. Everything above that cost curve is money in greater than money out. Everything below that total cost curve is going to be money out greater than money in. Okay? And look at this. We brought up this brings it all together. This is bringing it all together. Okay? We brought this up before. We said revenue was price times quantity. Here's our price. Here's our quantity. So this entire area, this rectangular area, is going to be revenue. This is our entire revenue. Well, given that entire revenue, this is our cost, the area below the average total cost curve, below the supply curve. This is our total profit, the area above the supply curve, above our total cost curve. Okay? Now let's walk through how we figure that. Since profit is revenue minus cost, cost is given by the average total cost times the quantity. Revenue is given by the price of the product times the quantity, which we've just talked about. Okay? Profit is revenue minus cost. So we simply are going to differentiate between these two areas. So what we're interested in then is the distance between the price of X and the average total cost for every quantity of X. That's going to give us per unit profit. The profit area is then given as the triangular area from the y-intercept to the price of X, and from the origin, which is where quantity equals 0, to QX. Okay, now let's put some numbers behind that to reinforce that in our brain. That's all very nice and all very hypothetical and theoretical. Let's put some numbers behind it. Okay? Again, this is the picture we just looked at. All right? Well, let's remember our high school geometry. What we're interested in here, this area here, okay, this entire square, price times quantity, this entire square area, rectangular area, is our revenue. Okay, this area here is our cost. All right, this area here is our profit. So what we're interested in for profit is this triangular space. Well, if I remember my high school geometry correctly, the area of a triangle is 1/2 base times height. Okay, it doesn't really matter which one of these two things, by the way, we use as base and which one we use as height. It's multiplicative, so we use the associative principle of mathematics. All right, 1/2 base times height. All right, now let's look at a numerical example of this. Let's say, for example, that our price is $10. Let's say that our intercept is $2. Now, again, I want to reinforce this. What does this number actually mean? This is the minimum point of average total cost. That's why lower than this, we will produce how many units? If we give a price of less than this, we'll produce less than 0 units. Okay? That's the price at which we'll produce 0, because that's our lowest average total cost. That's where we begin our argument. As I've said before, this then is the average total cost curve, which is also the supply curve. All right? This then is our area of profit. Okay? Well, 1/2 base times height. Let's say that we have a price of $10 and we sell 100 units. Now, first of all, just real quickly, what is our revenue? Well, our revenue is price times quantity. It's the area of this rectangular unit. Okay, 10 times 100. So we have $1,000 worth of revenue based on this. $10, 100 units. $1,000 in revenue, right? Okay, well, how much of that is profit? Well, this triangular space, that's going to be our profit. That's the area of revenue above costs. Okay? Each unit we sell, right, because average total cost is constantly going up, each unit we sell is going to yield us increasingly less profit. Same amount of revenue, but increasingly less profit. All right? So we figure out this. Well, 1/2 base times height. Then again, it doesn't matter which of these two things we use. Here, I typically use this for base. Okay? 1/2 base times height, that's 1/2 10 minus 2 times 100. Well, 10 minus 2 is 8. Half of that is 4. 4 times 100. 400 is our profit. Okay? Which means if that's our profit, okay, what's our cost? Well, this entire space is 1,000. 400 is our revenue, or 400 is our profit, so 600 is our cost. Right? 1,000 minus 400. And as I said, it doesn't matter which of these two things we use for base and height. If we used this as the base, 1/2 100 is how many? 50. Okay, times 10 minus 2, which is 8. So 50 times 8 is 400. Doesn't matter which one. Okay, it's multiplicative, so it's the associative property of mathematics. All right. Now let's go back to our ongoing example of the fish sandwich, because now, after all this time, I'm rather desperate to figure out exactly how much profit my little tavern's making off its fish sandwiches. Okay? Well, we calculated the supply formula. We calculated the demand formula. Okay? And we calculated from this formula just earlier in this lecture that our equilibrium was going to give us, our equilibrium price would be $6 and our equilibrium quantity would be 180. What does this give us for revenue? Well, again, as I've been stressing, it's this rectangular area. That's our revenue. Okay? Well, that's price times quantity. 6 times 180, $1,080. That's my overall revenue from the fish sandwiches. On a weekly basis, I think it was weekly demand, right? So that's a week. Okay? Which isn't bad. Okay? Now, the profit from this, what we've just figured out. Okay? We have our intercept here. What's our intercept? It's this. It's this A. Okay? Meaning, what does that mean? Again, stress through what that means. Work through in your brain what that means conceptually. Conceptually, what that means is that 6/7 of a dollar, which is I can't remember, it was 85 cents or something like that. That's our minimum average total cost for our fish sandwich. Okay, that's the point at which we're going to produce. Any price less than that, and we're not going to produce. Okay, because we'd be losing money per unit. So that's the point at which we produce. Okay, we continue to produce until supply equals demand, right? So that means that we're going to have this triangular space as our profit, which is to say 1/2 6 minus 6/7, okay, times 180 units. You'll notice what this is. This 6 minus 6/7, that's our profit per unit. That's the profit for the first unit. And that average total cost is going to go up. Okay, we could, if we wanted to, do it additively and look at each and every individual unit, which would be very painstaking and very time consuming. It's easier to recognize that, oh, well, you're dealing with just this triangular space here. Okay, so 1/2 6 minus the intercept, which is 6/7, times 180. And then I walk through the math here. This means yield. So, 1/2 6 minus 6/7 times 180 yields 1/2 42/7 minus 6/7 times 180 yields 1/2 36/7 times 180 yields 36/14 times 180 18/7 times 180. Our overall profit then is $462.86. Okay, and we could figure out then what our cost is too. Let me see if I can do this in my head real quick. It would be what our total revenue was 1,080. Our profit was $462.86. So unless I'm mistaken, our cost is $117.14. Is that right? Okay, or rather, $517.14. $517.14. Okay, simple enough. All right. Now, we want to move on to the idea of consumer surplus. The easiest way to do this in your head is by way of analogy. Consumer surplus is to demand what profit is to supply. Okay? In terms of what we've been looking at, in terms of supply and in terms of profit, another way of expressing profit, another way of a synonymous term, an analogy, is profit is producer surplus. Okay? Well, the consumer's going to have a surplus as well. And it's going to be figured out and given to us exactly the same way. And that's what I say down here. It's calculated exactly the same way. Same thinking as with producer's profit. We look at the triangular area defined by the distance from Px to the y-intercept of demand and the origin to Qx. Remember that the y-intercept for demand represents the maximum amount a consumer will pay for the product. Say a consumer, for example, is willing to pay $10 but only has to pay $6. The consumer therefore gets $4 in consumer surplus. Like, for example, the other day I went out to the grocery store and I bumped in best of all possible worlds. Walmart had Breyers ice cream on sale for $2 and $2.98. Okay, well, as it works out, the maximum I would even consider paying for a half gallon of Breyers ice cream is like $5. Okay, so when I'm paying, what they usually charge is like $3.85, so I'm getting $1.15 in consumer surplus. Okay, the amount I'm willing to pay minus the amount I actually pay, that's my consumer surplus. Okay, so when they drop it down to $2.98, I'm making mad consumer surplus. And one of the things that's really a lot of fun, we do it in the upper level microeconomics courses, in intermediate price theory, and then in economic foundations for decision making, is we work with different pricing strategies that soak up all of that consumer surplus and transfer it over to the producer. But now let's just work on how to calculate consumer surplus and figure out what it is. All right, and it's the same exact thinking that we just went through. So we can truncate this discussion a little bit. Okay, it's the same exact thing that we looked at before. Okay, here is the maximum amount that a consumer is willing to pay for the product. Okay, because the demand function is negative sloping, as demand increases, consumers are increasingly willing to pay less and less and less for the product. Here's the price of our product. This area here is what we just figured out to be producer surplus, what we called profit. Well, the antecedent to that is the distance from the price to the demand curve, to the maximum that a consumer is willing to pay for the product. Okay? And so we calculated the y-intercept for demand from the equation actually just earlier in this lecture as 12, meaning that $12 is the maximum anybody would be willing to pay for the fish sandwich, for the product. Okay, we calculated the price of equilibrium to be 6, the quantity of equilibrium to be 180. All right, well, to figure out consumer surplus, we're going to use the same thinking that we used when we figured out producer surplus, which we then called profit, and which we'll call profit again, because profit has fewer words than producer surplus, so it's easier to say and it's not as much of a mouthful. I wish we had a word, we could call it consumer profit, I suppose, but that wouldn't make any sense and would be terribly confusing, so we won't do that. We'll call consumer surplus, and we'll call producer surplus profit. Nice, I like that. That's the reason they do that. Yeah, okay. So for our consumer surplus, we just use the same basic thinking. Okay, it's this triangular space, 1/2 base times height. All right. Now, if we were to look at total consumer value, we could do that as well. Total consumer value would be how much they value it for, which would be this square space here. We don't want to get too into that. That would be the total consumer value that would be created. But at any rate, consumer surplus, 1/2 y-intercept of demand minus px times the qx times the quantity. Okay. Well, what we figured that out to be was 12 minus 6 times 180, 1/2 of that number. That's 1/2, 6 times 180, $540. So you see, what we have here is consumer surplus of $540. We have a profit of $462.86. And, I have to apologize for this, but I look at this, and whenever I look at this, it bothers me. Does it bother anybody else there? Any potential producers? Doesn't it bother you that the consumer is getting surplus? What this means is that the consumer is getting value. They're getting utility that they're not paying for. I mean, the fact is, if somebody's willing to pay $12, I want to charge them $12. Okay? Easiest way, okay, is what's referred to as first-degree price discrimination, where we haggle over the price. Okay? They do this in automobile dealerships. You haggle over the price. That takes away the consumer surplus. How much are they willing to pay? But at any rate, that's an argument for a different time. Right now, that's consumer surplus in a nutshell. Same thinking as we did with producer surplus, that we did with profit. Now let's look at this problem. Okay? Let's look at the demand schedule to the left. What are the price and quantity at equilibrium? What is the profit at this point of equilibrium? What is the consumer surplus resulting from this equilibrium? Okay? We're just going to employ what we just learned how to do, and we'll walk through it step by step in this problem. Okay? First of all, what's going to be the equilibrium point? Well, let's take a look here and just see if we can come up with it in our head. Okay, demand keeps going up, supply keeps going down. It looks to me like it's gonna be, let's see, somewhere in this area it looks like is where equilibrium's gonna be. Okay, drops from 500 down to 400. Somewhere it drops from 6 to 480. Somewhere in this area, that's just what my intuition looks at and tells me. But we can actually calculate it specifically. Now let's walk through it. Okay, first let's figure out our linear functions for demand and supply. This is what we've been doing throughout. We did this from lecture 3, did this from lecture 4. We'll just walk through it. P equals A minus BQ. 8 equals A minus, and we just walk through the math here. This gives us a demand intercept of 20 units. We can come up then, and then that gives us this function, P equals 20 minus 1/50th Q. We did this, I think we did this back in one of the problems for a week, I think week 2. We did this in one of the problem for week 2. We can come up with the inverse of this, 1,000 minus 50p. Then we deal with the supply curve. We do the same basic thinking. Again, this is just a reiteration of what we did before. Right? You can go back and look at lectures 3 and lecture 4 for a refresher if you need to, for how we come up with this. We then come up with the inverse function. Okay? So now half the battle is fought. Now what we're going to do is what we've learned in this lecture. Okay, in lecture 9, which is, well, equilibrium is where supply equals demand. Okay, so we're just going to set these two functions equal to each other. Once again, it doesn't matter which of the two we use. We could either say 20 minus 1/50th Q equals 2 plus 1/60th Q, in which case our unknown is going to be the quantity equilibrium, or we could say 1,000 minus 50p equals 60p minus 120, which will give us the price at equilibrium. We're then just going to take either of those and substitute for the other to figure out the other one, right? Okay. Okay, now this is what we've been talking about. We start with the understanding that equilibrium is where demand equals supply, where the two things are equal. We just calculated for product X based on that schedule that we used for this problem, that this is our demand function, this is our supply function. These are the inverses of those functions. Doesn't matter which one we use. Again, it's whichever one you're more comfortable with, whichever one. They're going to get you to the same point. They're going to get you to the same place. Okay? Me, I kind of like this one better because it doesn't involve the fraction. And so it's a little bit easier to use, I think. I mean, I can almost do this one in my head, right? This is going to be 1120 equals 110p. And then I do the division, or better yet, I have my calculator do the division, and you know, even my cell phone's calculator can do that. Okay, whichever we choose. And this is what we walked through at the beginning of this lecture. Once we found the one, either P or Q, we can find the other one by substituting it in the formula in the appropriate place. All right? Now let's walk through it. First of all, let's find QE. And I do it both ways just to kind of show you how we do this both ways. This is using the functions themselves rather than their inverses. This is going to find the quantity at equilibrium. And again, we can get to it either way. There's all kinds of different ways to do this. So it's really a matter of choice. Whichever you find simpler, whichever you find easier. All right? 20 minus 1/50th Q equals 2 plus 1/60th Q. That's going to give us 18 equals 11/300th Q. Multiply both sides by 300, you get 5,400 equals 11Q. Hence, our quantity at equilibrium is 490.9. Now, it depends on how we've set up the problem here. I didn't really say anything, but most of the time, unless it's otherwise designated, you're going to round that to the lower whole number. So, or in this case, we round it to the higher whole number. It doesn't matter. I'll whenever I give you a problem for points or anything like that, I'll be very clear on explaining what you want to round it to, so you don't have to make that kind of decision. We'll round it up to 491 here. Okay. Now, given the fraction, instead we could use the price at equilibrium. 1,000 minus 50p equals 60p minus 120. 1120 equals 110p. Divide both sides by 110. You end up with the price being 1018. Almost always, when we deal with a price, we'll round it to the nearest penny. Okay, so that's $10.18. It's not always the case that we're going to do that. Like in the economic foundations class, which is a master's level class, we'll deal with examples and we'll deal with problems that are like the supply of natural gas or the supply of water, where you'll bring it down to hundreds of a gallon. And like my water goes for, I think it's 0.35 cents per gallon. Okay, that's a little more complicated than we want to get into right now. We're just gonna simplify this. Say round your dollar figures to the nearest penny, and then follow the instructions as to what we want to round that quantity to. Some quantities can be subdivided, some can't. In this case, we round it up to 491 units at $10.18. All right, so there's going to be our equilibrium point. Now, if we found that Q, if we used the fraction and found the Q first, we simply substitute it in the appropriate place in the formula. So we end up with P equals 20 minus 1/50th times the Q, which was 491. Okay, that gives us a price of $10.18, which is what we just figured out using the other formula. Okay, and again, as I've stressed, it doesn't matter which of the two formulas you use for the substitution. Okay, because at that point in time, this is what we always want to keep in mind, is at that point in time, the two are the same. Demand and supply are the same thing at that point. So it doesn't matter which of the formulas you use. Okay, if we found P, we simply use the inverse formula. Q equals 1,000 minus 50 times the price. Gives us quantity 491. If you prefer, you can use supply. Q equals 60 times the price minus 120. Going to get you to the same place. All right. Now, here's the graphic representation of this. Very similar to what we had with the fish sandwich problem. All right. There's our supply function, 2 plus 1/60th Q, which tells me that this number right here is going to be 2. Right? That's the y-intercept, which is to say, let's keep this in mind, that's the minimum average total cost. This then will be the average total cost curve as we produce increasing quantities. This then is the demand function. Again, what this is going to tell me is the maximum price a consumer is willing to pay for the product. This was the equilibrium we just calculated, $10.18, 491. Okay, and now it's what we just kind of went over. The overall revenue will be this rectangular space, 10.18 times 491. Okay, the area of this rectangle. The profit will be the entire space above the cost curve. The cost will be the entire space below the cost curve. Okay, and we'll walk through that. We'll walk through that in just. All right. First, let's go through profit. Exactly what we just calculated. 1/2 10.81 minus that y-intercept of 2, which again is our minimum average total cost, multiplied by the quantity at equilibrium 491. That's going to give us a producer surplus, a profit of 2008.18. Consumer surplus we figure out kind of the same way. The maximum price somebody's willing to pay for it, minus the actual price, times 491 units, times 1/2, 2,410.81. All right. Okay, now just to finish everything up, this is what we've been talking about, and this is what we saw before with the fish sandwich example. Here's our supply curve. Here's our demand curve. We just looked at that. There's the functions. Okay, there's our minimum average total cost. There's the maximum that somebody's willing to pay. This is our cost curve going upwards. The area above the cost curve, that's our profit. We just figured that out to be 2008.18 with an extra dollar sign in there. I'm not quite sure why I put that in there. Call it a typo. The consumer surplus, this is the maximum they value it. This is the actual amount they pay. So this is going to be all the consumer surplus. And so this down here would be our cost. Okay, and I could ask you to figure out cost. How you would do that is really simple. You wouldn't have to figure out the area of this space. It's simpler than that. You could figure it out much more simply. You figure out your total revenue, which is price times quantity, and then subtract your profit from it, and that'll be your overall cost. And that concludes Lecture 9. In the next lecture, we'll deal with the equilibrium point and the movement of that equilibrium point when it comes to profit maximization and the profit maximizing level of production.